question comes under the sequence and series. So that's chapter number 10 in AP Calculus BC. So this concept comes only for Calculus BC. So which of the following series converges? So we need to check which of these things converges. So in these types of questions, we have to take each and every options and try to solve it. So if I take the first option, so which is 3n over n plus 2. So for this one, I will try to apply the nth term test. For option A, I will try to apply the nth term test. So the nth term test goes something like this. So limit n tends to infinity of 3n over n plus 2. So I can take out n common out both in the numerator and the denominator. So I'll be getting limit n tends to infinity. If I take out n common out in the numerator, I'll be getting just 3. And if I take out n common out in the denominator, I'll be getting 1 plus 2 over n. So n and n can get cancelled out. Of course, we can also apply the L'Hopital rule. So now 3 over 1 plus 2n. So if I apply the infinity, so 2 over infinity, any number over infinity would be 0. And this is basically 3. So whenever we get limit n tends to infinity is it's not equals to 0, then we say that one diverges. So this one clearly diverges. So which means option A cannot be the answer. And next, for option B, so what I'm going to do is I'm going to apply option B, we are going to apply the limit comparison test. So I'm going to compare it with 1 over n, which we know it's a harmonic series. So it basically diverges. So in the limit comparison test, all we need to do is limit n tends to infinity of whatever the equation we have it divided by 1 over n. So when I simplify this, these two things will get multiplied. So I'll be getting limit n tends to infinity of 3n square over n square plus 2. So I can take out n square common out similar to the previous part A. So I'll be getting n squared times 3 over n squared times 1 plus 2 over n squared. With a similar logic here, I'll be getting it as 3. So whenever we know this, whenever in the limit comparison test, so if we get any finite value, so both would diverge or both would converge here, because whatever we are comparing it with, that diverges. So this one will also diverge. So which means even option B cannot be the answer. And now if I talk about option C, so I can take out n common out and cancel it out with the denominator. So that's basically n equals to 1 to infinity. So if I take out n common and cancel out with the denominator, I will just have 3 over n plus 2. So if I just have 3 over n plus 2, and again, I'm going to do the comparison test, the limit comparison test with 1 over n. So we know this 1 over n, the summation of 1 over n diverges. So if I similarly do this 3 over n plus 1 divided by 1 over n, so we will be getting limit n tends to infinity 3n over n plus 1, n plus 2 basically. And I can simply take out n common and simplify it. So this is basically similar to this one. So we will be getting 3. And whenever it's a finite value, so both would converge or both would diverge. So in this case, the thing which we are comparing it with, that diverges. So that's why this one will also diverge. So even option C cannot be the answer because that actually diverges. And if I talk about option D, so option D is I can take out n common or basically factor out n and simplify it. So when I do that, so in the numerator, I'll be getting 3n over n square plus 2, which is exactly same as option B. So in that case, if I say option B diverges, this one will also diverge. So that is the reason option E is the right answer. But if I need to do it, how can I say it converges or not? So first of all, I can take out n and simplify it. So when I do that, so I'll be getting summation of n equals to 1 to infinity. So just 3n over n cubed plus 2. And we need to apply a limit comparison test with 1 over n squared. So if I do the limit comparison test with 1 over n squared, so we know the summation of 1 over n squared converges by the p-series test. So in that case, if I apply the limit comparison test, so that's limit n tends to infinity, that's 3n over n cubed plus 2 over 1 over n squared. So if I simplify this, I'll be getting something like limit n tends to infinity of 3n cubed over n cubed plus 2. Of course, if I solve it similar to the previous step, so that is by taking n cubed common out and simplify it, so we will just get 3. So whenever we get a finite number, both would converge or both would diverge. The thing which we are comparing it with, that converges, so that's why this one will also converges. And this is the right answer for this sum.